In this video, I'll go over how to determine the formula of an unknown compound. So we'll start with 0.1156 grams of the initial compound that's composed of carbon, hydrogen, and nitrogen, and it's going to yield 0.1638 grams of carbon dioxide and 0.1676 grams of water, so H2O. So we're going to start by determining the amount of carbon that is in the system. And we're assuming that no carbon was lost during the reaction. So we're going to take the 0.1638 grams of CO2. We're going to times that by the molar mass of carbon, which is 12.01 grams, and then divide that by the molar mass of carbon dioxide, which is 44.01, which the units of grams of carbon dioxide cross out, leaving you with the grams of carbon, which we find to be 0.0447 grams of carbon. And you're going to take that in order to determine the amount of, the percent of carbon in the initial compound. So 0.0447 grams of carbon divided by 0.1156 grams of compound. And that's going to equal 0.3867. Then we're going to do the same for the hydrogen. So we're going to take the mass of the water that was made, times that by the grams of hydrogen, it was 2.02, and divide that by molar mass of water, which was 18.02. Grams of H2O cancel out. That will leave you with 0.01876 grams of hydrogen, which it's in terms of H2 because that is what was created in the output of the reaction, which is H2O. So now we're going to take that weight of the carbon, 0.01876, divide that by the 0.1156 grams of the compound, and we're going to see that is equal to 0.1623. Now to determine the amount of nitrogen in the system, so we're going to take 100%, so 1 minus the addition of 0.3867, so the percent of carbon plus the percent of the hydrogen, 0.1623, and that's going to be equal to 0.4510. Alright, and then now we're going to assume 100 grams of the, alright, now we're going to assume 100 grams for the system. So by doing that, we're able to know that there's 38.67 grams of carbon in the system. We're going to times that by 1 mole of carbon, and divide that by the molar mass of carbon, which is 12.01 grams of carbon, and the grams of carbon will cancel out, leaving us with moles of carbon. And that will give us 3.22 moles of carbon. And we're going to do the same process with the hydrogen, the nitrogen. So 16.23 grams of hydrogen times 1 mole of hydrogen divided by 1.01 grams of hydrogen, and you're going to get 16.10 moles hydrogen. Now we have 45.1 grams of nitrogen times 1 mole of nitrogen, and 14.01 grams of nitrogen. Units cancel out, leaving you with 3.22 moles of nitrogen. So now you take the smallest amount of moles, which in this case is 3.22. You're going to divide each of the moles of the element that you found by 3.22. So for carbon, we're going to have 3.22 divided by 3.22, and that's going to be equal to 1. For hydrogen, we're going to have 16.1 divided by 3.22. That's going to be equal to 5. And then for nitrogen, we have 3.22 divided by 3.22. That's going to be equal to 1. So these are the amount of atoms that are in the empirical formula for the compound. So there's 1 carbon, 5 hydrogens, and 1 nitrogen. So that means that the empirical formula was CH5N.